Hi. In the last video, we learned some properties of factors. So in this video, we are going to discuss how to calculate number of total factors of a number. For example, my number is 3600. So I want to calculate all the factors of this number 3600. So as in the previous video we have seen, the first factor will have its partner number, which when multiplied with it, this will give us the 3600. Similarly, second factor will also have a partner and so on. But in that way, if we are going to write all the factors of this number, this task is going to be very troublesome. So what we have to do? So first step is prime factorize this number. So how to calculate prime factors of this number? So sometimes we have learned in schools, like you draw it like this, 3600, you divide it by 2, it goes like this, it is 1800, you can again divide it by 2, you will get 900, again with 2, you will get 450, again you can divide it by 2, it is going to be 225, after that it is not divisible by 2 anymore, but it can be divisible by 3. So I can divide it by 3, it's 3 7s are 21 and 1 3 5s are, it still is divisible by 3, again with 3 if I divide it, I get 25, and now no more 3, but it is divisible by 5 and 5, I'm done now. So in all, this number has 1, 2, 3, 4, there are 4 powers of 2, it means I can write this number as 2 raised to power 4 into, I have 3 also there, so how many 3's? I have 1 and 2, there are 2 3's, so there is 2 power of this number 3, and the next prime number I have in this number is 5, so it is 5 square. Right. Okay, one more thing. So do I need to do all this thing every time? I can do that, but I can skip this also. So what can I do? That also we have learned in our schools. So we can write this number, we can break this number in the bigger factors which I'm aware of. Say I can break this number 3600 as 36 into 100. Right? And 36 now I know it is 4 times 9 or 2 square into 3 square. 4 times 9 is 36. Similarly, 100 means 10 square or 2 square into 5 square. So in all I get 2 raised to power 4, 3 square and 5 square. Okay, so that's all. Now, how to calculate number of factors of this number? Now see carefully. When I'm going to write the list of factors of this number, 2 will certainly be in the list of factors, 3 will also be there, 5 will also be there. Will 7 be there? Certainly not, because 7 is not contained in its prime factorization. So that's obvious that the prime numbers which are there in the list of this prime factorization are going to be there in the list of all the factors of this number. And also, will 16 divide this number? 16 means 2 raised to power 4. Yes, I have 2 raised to power 4. Will 32 also divide this number? No, because 4 is the highest power of 2 which can divide this number completely. So we can conclude that whatever powers of these prime numbers are there to its maximum extent, they will be available, they can be available in the list of factors, but no power greater than these ones can be in the list of factors. So, but smaller powers can be included. So for powers of 2, I can take 2 powers 0 or 1 or 2, 3, 4. These are the 5, 1, 2, 3, 4, 5. These are the 5 possible ways I can select a power of 2 in my factor. Isn't it? Because it is not necessary that my factor should contain 2 power 4. It may have lesser powers also. Same goes with other powers also. So for powers of 3, I can take 3 powers 0, 1 or 2. There are 3 possible ways. And to make the combinations, I can combine any of these 5 with any of these 3. So say 2 power 0 can be multiplied with 3 power 0 or 3 power 1 or 3 power 2. There are 3 ways. Similarly for 2 power 3 also I can multiply it with 3 power 0 or 3 power 1 or 3 power 2, 3 ways. So for each of these 5 cases, I have exactly 3 ways each. So in all, I have 5 times 3, that is 15 combinations. But that is only for powers of 2 and 3 so far. If I go for powers of 5, I have again 3 ways, 5 power 0 or 5 power 1 or 5 power 2. So in all, I get total number of factors for this number. I am writing it as, in short, number of factors, NOF. So it comes out to be 5 times 3, that is 15, times 3, that is 45. Oh, it's odd number. Why it is odd number? We've discussed that in last video. For a perfect square, number of factors are odd in quantity because its square root will come in exactly middle of the list. Okay, so that is the number of factors of this number. So in general, what can I conclude? That to calculate number of factors of a number, first I need to write the number in its prime factorized form. Say P1, P2, P3 are the different prime numbers in my number, and so on. There can be more also, and the powers are say A, B and C, like this. So how to calculate number of factors? So for number of factors, I just need to make the combinations of different powers of these prime numbers which can be included in the list of factors. So for p power 1, I can have p1 power 0, 1, 2 up to a. So there will be total how many cases? A plus 1. Just like here. Here it was 2 raised to the power 4. So from 2 power 0 to 2 power 4, I had total 5 cases. So similarly, in this case, I'm going to have a plus 1 ways to select a power of p1. Similarly, b plus 1 ways to select a power of P2, and C plus 1 ways to select a power of P3, and so on. So this becomes our general formula to calculate number of factors of a number. Alright, so whatever questions do we get, they have some specific constraints sometimes. For example, for say the same number 3600, if I want to calculate the factors of this number which are perfect squares, say perfect squares. So question goes like this: how many factors of this number 3600 are there which are perfect squares? So how do I get to know whether a number is perfect square or not? Just by seeing the prime factorization? Yes, it's obvious that for a number to be perfect square, I must be able to write it as product of two equal numbers. So product of two equal numbers, it means when combined, it will be having all the prime numbers in even quantity so that they can be divisible, they can be divided in two equal parts equally. So for 2 powers of 2, I can select 2 power 0 or 2 power 2 or 2 power 4, because 2 power 1 cannot be split as product of two equal positive integers. Similarly, 2 power 3 also cannot be done like this. So 2 power 0 or 2 power 2 or 2 power 4. So I have exactly 3 ways to select any power of 2's. Similarly, for powers of 3, so remember what we are doing, we are finding the factors of this number which are perfect square numbers. For a number to be square number, what we have discussed, that powers should be even in quantity. So 3 power 0 or 3 power 2, these are the only 2 cases which can be included in this factors list. So there will be 2 cases. And for powers of 5, again I can select 5 power 0, 5 power 2 only. So there are exactly 2 more cases. So in all I get 3 times 2, which 6 times 2, it is 12. So there are 12 factors of this number 3600 which are perfect squares. I hope it is clear. Let's take one more example. If I want to find out factors of this number which are say multiple of 5. Multiple of 5. So how can I conclude whether a number is multiple of 5 or not? It's simple. For a number to be multiple of 5 and its prime factorizes formation, it should have 5 as a factor. Which means among the powers of 5, 5 power 0, 5 power 1 or 5 power 2, my number should contain at least one power of 5. It means I cannot include 5 power 0, all other powers are valid. And is there any constraint on powers of 2 or powers of 3? Certainly not. When I want a number to be multiple of 5, so I'm not saying that it should not be multiple of 2 or it should not be multiple of 3. It can be, or it may not be also. So that means all powers of 2 and 3 can be taken. So for powers of 2, I can take each of the 5 cases. So there are 5 ways to select a power of 2. Similarly, to select a power of 3, I have all these 3 cases. There are 3 ways possible to select a power of 3. And for powers of 5, as we have just discussed, that 5 power 0 cannot be there. At least one power of 5 should be there. So I have only 2 ways to select a power of 5. So there are 2 cases for that. So in all it becomes 5 times 3, that is 15. 15 times 2, that is 30. So that means out of 45 factors of this number, 30 are there which are multiples of 5. I hope it is clear. So you can have many more constraints and you can accordingly simplify and calculate the number of factors in that manner. Thank you.